Uh, all right. Hey, everyone. Thank you so much for coming. I love to see that room is packed. Right. My name is Anton. I'm a Principal Solutions Architect for serverless at AWS. My co-speaker today is also Anton, so you're getting two Antons for the price of one. He's the author of serverless.tf framework. And today we'll talk to you about how to use Terraform for building serverless application. Now, a little spoiler alert, we have a lot of content today, right? At the very end of the session, we have a huge QR code that will take you to a page with all the content that you're going to see today, including slides. So you'll get those slides in about 59 minutes, okay? So you still can take pictures, but in 59 minutes, you'll get these slides as well. All right, let's get started. So when you registered for this session, you probably saw this huge abstract, right? So what we wanted to do is to make sure that we fulfill our promise. So we took the most impactful, important things, and we built our agenda to actually address those things. Today, we want to talk to you about how do you build and test your serverless applications with Terraform, how do you scale and deploy those applications, and we also want to make sure that we wrap up with actionable items, something that you can take home and start applying to your environments as early as next week, okay? Quick show of hands. How many of you are already using Terraform? All right. Terraform for serverless. All right, a little fewer hands. Awesome. You're in the right place. OK. Big question. Why do we even need to have this session? What's so special about using Terraform for serverless, right, that we have a dedicated packed session? And the answer is serverless applications are a little bit different, right? So if you think about traditional applications, you usually have that application layer, and this is where your application development teams live, right? And you have the infrastructure layer, which is usually pretty thick, right? And there's this rigid separation between infrastructure and applications team. They're not always best friends, right? DevOps forever, but they learn how to work together. But their processes, their tools, sometimes even their language, they're not always aligned, right? So you have coupled manual workflows, long cycles. I believe you've all seen that, right? Now, when we take this into serverless world, on the other hand, the notion of infrastructure, especially when we talk about infrastructure as code, is a little bit redefined, right? So you have less of those EC2 instances and RDS. It's still there, but that layer is significantly slimmer, right? And your infrastructure is essentially are components of building blocks of your applications. So a Lambda function, technically you use infrastructure as code to create that, right? But it's not really a traditional infrastructure, right? It's something that application developers own, and they want to control it. They want flexibility to make changes, whenever they want, right? So serverless world, this definition changes a little bit. Those are not just infrastructure resources, there are application resources. Infrastructure as code tools as such are no longer exclusive to infrastructure as code, to infrastructure teams, right? We're seeing a lot that application development teams are getting on board with infrastructure as code because this gives them a way to more efficiently build their application. And the last one is IAC no longer just stands for infrastructure as code, right? It starts to also represent integration as code because in serverless world, those building blocks, right, that's not the only thing that you define with infrastructure as code. The arrows between those building blocks are also defined as infrastructure as code using the same Terraform and similar tools, all right? So this brings us to this new interesting world where application development teams are using infrastructure as code. You have infrastructure teams still using their infrastructure as code tools, and they need to work together, right? And application teams, they consider many of those things like Lambda functions and event bridge rules as application resources, while infrastructure teams consider that as their infrastructure and they want to have more control. How do they work together? Well, Terraform, right? We've seen a lot of success, right, when both teams, application developers and infrastructure, using the same tool. And this is what our session is going to be about, right? Now, for this specific audience, I don't think I need to talk about what Terraform is, right? We'll leave it for a very different session, right? Same for serverless, right? If you know what Lambda functions are, you're good, right? And it's 3 buckets. That's enough knowledge that you need for this session, okay? So we'll gradually build. We'll start with a simple scenario. We'll gradually build and introduce more and more complexity into this discussion. But let's start with actually building something, right? Now, we'll build a rather simple application. And again, spoiler alert, you will not see this application in action. Why? Well, because I don't care about business logic. I care about the infrastructure as code part of this application. I don't care about whether it's written in Python or Node or whatever. We care about the definition of this application. So it's a basic greetings application. It receives messages from SQS, right, using Lambda function. And based on that message, it pulls an image from one S3 bucket, converts that to HTML, and saves it to a different S3 bucket. Pretty simple. And again, right, you will not even see it in action because we don't care about business logic in this session. Now, what do we need, right, from the Terraform perspective to build this application? Now, I would probably start with something as simple as SQS queue, right? So this is your Terraform resource for creating that greetings queue, right? And there's one interesting thing that you see here right away, right? It's not just the queue name, but also SQS managed SSE enabled equals true. So using the infrastructure as code, you're not just defining that resource, you're also implementing some best practices for that resource. Let's see if this stands for other types of resources. So we're going to be adding a couple of S3 buckets. Remember the diagram, right? This is how you create S3 bucket with infrastructure as code, with Terraform, right? But when you create an S3 bucket, there are several best practices that we recommend, right, as AWS. So for example, we highly recommend you define ownership control. We highly recommend you define access control. So when you, as someone who creates that Terraform configuration, building those resources, you can actually encode those best practices into your resources. Let's get into more complexity, Lambda. Now, before you create that Lambda function, you need to create an execution role, right? Essentially define permissions of what that Lambda function is allowed to do. Now here, remember the use case, I got two statements, two permissions. My function can get object from the source bucket, right, and put object into destination bucket. So this is one of my favorite things, principle of least privileged access, right? I can only read from the source and write to the target. This is probably what every security review AppSec person will ask you to do, comply with principle of least privileged access, and it's super easy to do that with Terraform. Now that we have our execution role, let's actually create a Lambda function. Now, if you've ever created Lambda functions with infrastructure as code, you know that there are 3 different ways of doing that. Depends on your function. The most easy way, right, the most straightforward, is build a zip package, essentially take your code, zip it, right, and upload it to a Lambda service. That will create a Lambda function. This is great for when your functions are up to 50 megabytes zipped and quarter gigabytes unzipped. So there are some limitations there, but that's the easiest way. Usually great when you're prototyping, when you're building something relatively small. Now, another approach is when your functions are getting larger, is you can still zip it, but instead of directly deploying that to Lambda, you upload it to S3. Right? And from S3, you create your Lambda function. This will allow you to overcome that limitation of 50 megabytes zipped function, right? And also will leave you with a trail of all the deployed packages in S3, right? So if you need to maintain a trail of all the packages that were ever deployed, you got it right here. The third option is if you're already part of the containers ecosystem, if you like building your code as containers, you can build your code as a container, Docker build, deploy that to ECR, right, and create a Lambda function from ECR. This is great if your functions are up to 10 gigabytes in size, right? So if your functions are large, if you're pulling in some frameworks, large frameworks, LLM frameworks, this is, that's the approach that you should take. Now, from the Terraform perspective, let's take a look. Now, on the very top, you can see the simple approach, right? This is what we use to basically package source directory of my function. Okay. Now, once packaged, below that, you can see the function configuration, things like function name, role handler, etc. And at the very bottom, file name and the code hash, right? So essentially, I'm referring to the package that I've created, the zip file I've created at the very top. Pretty simple. If you build your functions differently, for example, through S3 or through ECR, a large segment of this remains as is. But depending on your approach, you can either pull it from S3 bucket, right? You can define basically what's the S3 source of your code or the URI of your image. So all of these options are supported, right? And let's say at this point, I've built my application. I got my queue. I got a couple of buckets. I have a Lambda function and permissions. What's the next step, the logical next step as a developer? What do you think? Testing. Testing. Never forget about testing, right? Before deployment, actually, right? So I would probably want to test my whole setup somehow locally, right? Developers love testing locally before they deploy. So in order to achieve that, we have a tool. Anyone here familiar with SAM? Okay, a few people. It's a CLI tool, right, that comes as its own part of infrastructure as code, but we're ignoring that for now because we're using Terraform. But SAM also gives you ability to test your functions and APIs locally. It will download Docker image and simulating Lambda environment, and it will literally run your code locally. So I got a quick demo to show you how this works, right? So we're using AWS CLI here. We're using Terraform, one of the recent versions. Right? And we're using the SAM CLI. So let's run 3 commands. So you would see I'm actually in a proper Terraform structure. I got modules, I got my main.tf, and everything, right? So the command that I'm running is SAM local invoke and specifying the name of my function. And that function is defined in my Terraform configuration. So you can see some magic, and at the very bottom there, you can see the response from the function. So if you ever executed Lambda function in the console or through any other means, those logs will look familiar to you, right? You have the start of the execution, you have the end of the execution, you can see the employee ID, right, and the source file, the JPEG image. At the very end, you can see the body of the HTML that was generated. This whole thing ran locally, fully 100% locally. So if you're doing performance testing, probably not a good idea to do local performance testing. But if you're testing business logic, this is great. Even before you deploy it to cloud with Terraform Apply, you can test the business logic locally. Now, SAM is great if you need to simulate Lambda and API gateway. It simulates these two services locally. If you need to simulate a larger ecosystem, additional services, there is a product called Local Stack, right? You can find it on the internet, and they're actually at the expo if you want to talk to them. I'm not going to focus too much on Local Stack, but the idea is they can simulate several dozen AWS services locally, including Lambda, including HotSwap. Anton will be talking about that a little bit as well, right? So if you're not familiar with Local Stack, actually quite convenient tool to simulate a lot of different AWS services. OK, we've built our application. We've tested our application. The next logical step is before deployments. Well, there were a lot of various best practices as I was talking through my slides, right? And a natural question is, yeah, this is great. This dude works for AWS, right? But how do I know about these best practices, right? How do my company, right, my organization, which has 50 engineering teams, how do they know about these best practices? So essentially, the next question is, how do you scale? And when I'm saying scaling, I don't mean like going from 5 requests per second to 500 requests per second, right? That's something that serverless will kind of take almost fully automatically for you, right? I'm talking about things like growth challenges. How do I make sure that my development teams are only using approved runtimes which were not deprecated yet? How do I ensure proper, consistent project structure? How do I apply best practices at scale? How do I uniformly apply tags? You have no idea how many times I'm having discussions about what I call orphaned resources, right? Essentially, we have this 500 functions or whatever the resource is. We have no idea where they're coming from. Help us to find the owner. Okay? So how do you solve those growth challenges efficiently in your organization with Terraform? And the answer is actually, well, simple to say, but it takes some effort to apply. Modularization. It's a standard Terraform practice. If you're using Terraform here, you're familiar with modularization. So I'll talk about modularization in serverless context. The idea of modularization is just as you would do with any source code, you will not write your whole application in a single file, right? That's not going to scale. It will work, but definitely not going to scale. You need to break down your infrastructure as code to smaller pieces and make sure you define interactions, connections between those pieces. Now, this will give you 3 things that I want to talk about today. The first one is best practices, right? When you create your serverless resources using modules, right, you can apply those best practices across multiple teams in your organization. The second one is reusability, okay? Module is essentially encapsulated piece of something that was created with best practices in mind, and you can reuse it. It's highly reusable. The third one is composability, right? You're not just reusing those modules. You can compose those modules, as you will shortly see. Now, let's take a look at the examples. For those who are less familiar, there were a few people who were not using Terraform. For those who are less familiar with Terraform, essentially Terraform module is a set of inputs. You define your inputs, you define the outputs, and you also define the resources that need to be created, right? Now, those file names, variables, outputs, main.tf, they're a convention. You can name that whatever you want, right? You can use it, you can write Anton.tf, it will still work, right? But essentially, modules defined by input, what you create, those resources, and the output. Now, here, for example, you can see input function name. Then I'm creating a Lambda function with that function name, and I'm outputting the ARN of that function. This is probably as simple as it gets, right? And those of you who are experienced with Terraform probably already saying to yourself, this is one really, really useless module, right? There's absolutely no point to this module because it's just taking one variable like name and applying that to a resource. But let's extend that. So I'm introducing another variable, and I'm calling that variable runtime. And I'm setting a default value for that variable, okay? So now my module allows consumers of that module to pick their own runtime, but I also providing them with a default. So it's a very important thing, right? So can developers consuming this module make changes to this? Yes, they can. But do they have to? No, they don't. Okay, that's the best practice, right? Essentially, they don't need to spend their mental resources on figuring out. This is provided by the module. Let's take it one step forward. A very popular thing that I see, log retention days, right? Very popular example. If you're using CloudWatch, by default, logs are retained forever. Okay, I'm not sure you want to be paying for that storage forever, right? So another example that you can apply in your infrastructure as code template is how many days you want those logs to be retained for, okay? And on the left side, you can see the variable, but on the right side, actually, a few interesting things are starting to happen. So I'm not just changing the resource, the Lambda function resource, the logging config property, right? We've seen that before. I'm also creating additional resources. So based on the configuration variable, right, I'm creating a set of resources in my module, okay? So I'm changing essentially how this module will define a Lambda function. A few more examples that I see being very popular. Clicker, okay. So I see this applied heavily for observability scenarios, right? So here, for example, you have a more extended logging config, which defines the default log level, the system log level, the format of logs, the log group, and also enables traces, right? As a developer consuming those modules, right, you mostly care about your business logic, right? Observability and security, you care about them, but first you want to write your code. So with this approach, essentially, you're allowing your developers to base their code on the best practices that you've configured. And you're also enabling standardization across your company. Another example is using layers, right? How many of you are using layers with Lambda functions today? A few. Right, so layer is it's a capability of Lambda that allows you to inject additional, it can be code, it can be library, right? Essentially, as a separate layer of the function, so decoupled from the function code, right? For example, you have a layer for power tools. That's our open source frameworks for developer productivity, right? You can either tell every single development team in your organization, well, figure out which version do you need, power tools, do you need it or not, right? You're on your own. Or you can say, you know what? There's this module for creating Lambda functions, and it comes with power tools built in. And whenever there's going to be a new version of power tools, we'll update the module, right? So you'll get the latest version automatically, right? This can be anything besides power tools as well. Various observability frameworks, right? Various security and governance frameworks. So layers bring you a lot of different capabilities. All right, let's continue. So you've implemented all of those best practices and wrapped that as a Terraform module, okay? What's next, right? Well, that module will have some variables, right? Something that you've defined as things that developers can change, right? It will have outputs, things that developers can essentially take and bring to their composable architectures, as you will see. Inside of that module, it's up to whoever created that module to define what is being used as best practices, right? Now, this is just one module. You can create multiple of those. Right, so here, for example, you have 3 examples that I see quite frequently. A Lambda function with periodical scheduler. So it's a pretty common task to use Lambda for periodic processing because Lambda scales to 0, and you're not paying for it if you're not actually using it. So triggering Lambda function once a day to do some processing, right, and then you're not paying for that compute anymore. Pretty common scenario. Once again, using Terraform module, you can actually create something reusable, right, and reduce the mental burden, right, the mental overload on every other team that needs to implement that. SQS queue with redrive, also very common scenario, because sometimes messages from SQS queue needs to be redriven, retried. You can build a module out of that. Baseline Lambda function, that's what we've discussed previously. And then interesting thing starts to happen. So this is 3 different composable modules, right? But they are modules. Each one of them is independent. And you know what's the difference between those 3 modules and the serverless architecture? This, right? Now that I've added just 2 arrows, now this is an architecture, okay? And I have a function that does some periodic processing, pushes the data to SQS queue that supports redrive, right, supports retrying, and then pushes that for Lambda that pulls that asynchronously and does additional processing, right? So once again, 3 decoupled patterns, 3 decoupled modules that can be composed in any way you like. Architecture, serverless architecture, okay? The life cycle of those Terraform modules would be dependent on the company, dependent on how do you deal with Terraform modules already. What we see common, what we see successful in the industry is there's a platform team, and it's not always a well-defined platform team, right? It can start as a set of a few serverless enthusiasts that will start creating those modules, and over time they will turn into this serverless platform team. This can also be the traditional platform team, but essentially there are people who are starting to create those modules, right? And they're putting those modules into some sort of repository. It can be as simple as Git, right? Those modules are consumed by application development teams, and over time, since those modules represent application components, they do not represent infrastructure that developers care less about. Those are application components. Over time, the application development teams, they're starting to contribute to those modules, right? Because it's one thing to go to that platform team and say, hey, I need a change, I will open a feature request for you, and a very different thing, right, for development teams to basically open a PR that can be validated, right? As a result, those development teams are facing significantly less cognitive load when they need to implement serverless architecture in a proper way, right? They're just getting best practices from those modules, right? And they can reuse those modules to build their architecture. So to summarize the journey to scale part, right, something that I see quite common, right, I see organizations start with Terraform resources. This is where we started as well. right? So when you start your journey, you build your applications with plain Terraform resources. You go to the documentation, you use the AWS provider, and you're starting to build your applications. Now, it's not like an official term, right? I call it maturity level beginner, right? This is where all of us have started. This is where I started. As you mature, as you're getting more Terraform experience, you're starting to write your Terraform modules, right? You're starting to build stuff that you actually see that needs to be reusable, maybe by you personally, but maybe also by other parts of your organization. And this can be things like we've discussed, SQS queue with redrive, periodically invoked Lambda, VPC attached Lambda, right? It's a common scenario, especially in regulated industries, to attach Lambdas to VPC, and so on and so on. So this is what I call advanced. Now, the next level is when you actually discover that, hey, I'm not the only one who's writing those modules. There's a huge community out there that are creating those modules, and some of them are open sourced. And this is where you're starting to compose your applications from modules that you wrote and modules that you can find on the internet. Just like you would do with source code, like you can go to NPM or Maven and get some frameworks and dependencies. You can do exactly the same thing with Terraform modules, right? Some of them are written by you, others are created by community, and you're building your applications essentially from those vetted modules, implementing best practices. This is what I call power user. Now, one of those frameworks is serverless.tf. It's a community project, fully, open source, 100% open source, opinionated, right? But, I think you can tell a better story about it.
Oh, yeah. Sounds familiar.
The author.
Hello, everyone. Yeah, well, I can hear myself, but I hope it's OK, jet lag. So, yeah, serverless.tf is a community project, which is, as Anton mentioned, is 100% open source. The only thing which is kind of opinionated is that a few years ago, I looked into, OK, what people are missing when they're building a serverless application on Terraform, and it turned out that they're missing everything. Because there were no tools to develop applications, to build packages, to deploy them somehow, to secure. So that's where things started. This URL, serverless.tf, has some documentation, it has some links. Overall, serverless.tf consists of Terraform AWS modules for most common serverless services, like you can see on this slide. The main one is obviously Lambda, because Lambda seems to be used for so many different things that it can be, that's not a big surprise that there are books written just about AWS Lambda, right? Because you can do quite a lot with that. And all other services also used in the combination to bring different architecture kind of alive. So during next about 20 minutes, I will be talking about different features of different serverless and Terraform kind of use cases. And if something is not clear, then I'm pretty sure that we can chat about this later. And also, I want to say big thanks to everyone who's using these projects and to everyone who contributes to those projects. So clap to yourself, and thank you very much. Yes, I know that many of you clap inside. So. OK, so Terraform AWS Lambda module started because there was almost no way to package Terraform package or Lambda packages for different environments. And a very important aspect in this is that if you use a data source, which is called archive file, it will not give you even 50% of use cases, which you really need to achieve if you are building, let's say, for different platforms, if you need to install different packages, if you want to build for different platforms, architecture, sorry. That's why this package has been created. Now it's a little bit monster, and I don't want to look into it anymore, but it exists, and thousands of people use it daily. Different features were added into this packaging capability specifically for different runtimes. So if you use Node.js, you can just specify that you want to use runtime Node.js 20, for example, and you can just specify source path. Inside of that source path, it will look if there is a package JSON file, and it will install dependencies, and it will make a package out of it. You can imagine that it can be quite a lot of work, and that's one of the initial feature which we wanted to build inside of it. Then we did similar thing for Python, and over time we added more and more support for other runtimes. Also, there is support for different Docker capabilities. For example, you can build package inside of Docker. You can provide your Docker file. You can pass through your SSH agent to be able to access your private Git repositories, for example, or private PP, and so on. So we also added functionality to build it with Python and Poetry, which turns out to be just one line added, where we can specify Poetry install equal true, and this module will understand what has to happen, and it will do this work. You can also see that source path can be of very different types. It can be a list of different structures. It can be pointing to specific file. What source path will do is that it will execute each of these steps sequentially, and it will just build, and at the end it will produce one artifact which you can either deploy immediately or you can copy it to S3, for example, if you want to deploy it later. So that's a really important functionality of this Lambda module. Also, of course, who doesn't speak about Rust, right? I mean, let's rewrite everything to Rust. So now you can do this with the Terraform AWS Lambda module, because there is a way to build packages using Cargo Lambda library, and also it is shown how to build it for how to build Rust Lambda package using this module. All of this is open source, obviously. So another aspect which is very important is that there is a way to test, as Anton mentioned earlier. We can use local stack to emulate environment instead of deploying to AWS and calling it AWS endpoint. We can have our own local copy of different AWS services, and we can instruct our Lambda function to source from a bucket which has specific name. In this case, it should be always called hot reload, and we provide key to the folder where our application is located. Then we install a couple wrappers for Terraform and for AWS CLI to instruct it that instead of going to actual AWS, it should go to localhost where local stack is deployed. And then we can use AWS local CLI wrapper to invoke this Lambda function like normally. So this allows us to completely avoid using AWS, although it sounds pretty funny, right, to talk about avoiding AWS at reInvent. But you get the point that you can have quite good test coverage running local stack locally. I find this way extremely useful because you can test your business logic very nicely on your laptop. Obviously, performance testing and other ways of testing is not suitable for local stack. So let's talk a little bit about cross-service integration. And if you are not using packages provided by serverless TF or Terraform AWS modules, or pretty much any Terraform modules out there, what you will have to do is that in order to integrate your API gateway with Lambda function, you will have to create something like 10 Terraform resources just for API gateway, because you need to create a bunch of different resources, methods, integrations, deployments, and many, many other things. Plus, you also need to create a lot of IAM resources for that. Also, you need to have Lambda function and a bunch of other IAM-related policies and roles, and you need to figure out how to connect these approximately 20 different resources to implement pretty straightforward pattern, which is API gateway talking to Lambda function. And if you use a solution provided by serverless CF, or honestly, pretty much any Terraform AWS module, you will have to invoke just a couple modules, like in this case, invoke an API gateway and specify that the route of API gateway has to have an integration with Lambda function, and Lambda function should have allowed triggers, because you want to allow this Lambda function to be invoked from a certain API gateway endpoint. That's pretty much it. You don't have to deal with internal complexity and write Terraform code and need to be familiar with the logic. As a user, you just have to invoke a couple modules, and that's pretty much it. There is pretty detailed instructions on how to implement a lot of integration patterns on serverless land. I think 1 year or maybe even 2 years ago, I contributed these patterns there. If you want to contribute more patterns and maybe fix some of those patterns, maybe they stop working, please do so. All URLs will be at the end. So I find this website very useful if you're learning about serverless in general, and there is pretty big amount of information about different Terraform-specific features. So please check it out. Now let's talk a little bit about project structure that really works, right? As we can understand that there are infinite amount of ways to structure it, I want to highlight a few key points when it comes to project structure, which to my mind and to in general, best practice experience from what I have works. So first of all, monorepo works significantly better for having infrastructure as code as well as application code in close proximity, preferably in separate folders, but in one repository. That's really important. Also try to keep your project as modular, because this way you can simply understand where scope of one ends and where another. So don't try to put your Python and Terraform files in one folder and enjoy the mess. It's not fun. Also, if you have your environments and you have separation by directory, it will be easier for you to understand how certain environments are orchestrated. Like you have different folders with different configurations. It's easier to understand than having everything in one folder. Also, if you have dedicated variables files, you will be able to implement your scripts in a way that you provide variable files and have them very fine-grained for different services, for different regions. So this kind of structure works very well, that you can understand what are you trying to achieve. When you run plan, you provide specific files instead of providing things, for example, like this. When you specify variable values inline, it's okay if you have to do this once, but it's pretty hard to scale and pretty much impossible to maintain over time. So when you have these files in TFRs, you will be able to compare them, and you can just get better results in general. So if we look into this project structure, we can also see that when we have TF var files and resource configurations structured in exactly the same name, then we can easily understand what kind of Terraform module has what values does it have. So the structure here is that we have environments folder, and then inside of environments folders we have different Terraform TFRs files, which will be loaded specifically at which module you are trying to execute. And also, if we look into different ways how we can share this information, that's where things start to get more exciting. Default way for most people is to use Terraform remote state, where we can use something like this. So imagine the situation where you have different teams and you need to pass values between them. For example, you have Edge team who is responsible for configuration and for parameters of an API gateway. And then you have different application teams who are working specifically with Lambda functions configurations, but they don't necessarily have access to parameters of an API gateway. They, for example, may not know which IRN of an API gateway they can allow execution for the Lambda function. Of course, they can do this kind of research and ask them, but imagine that this separation is not known right now. And also, there is traditional set of resources like VPC and RDS, which is managed by infrastructure team. So one kind of amazing way is to send message and say like, hey, what's Lambda IRN I can attach? So Bob is doing a bad job. Bob shouldn't use email. Bob should use something else. Because we can easily understand that if you reach out to somebody on Slack and ask like, hey, where should I do this? Right? I mean, we all have this situation where we find it much more convenient to ask somebody and like, hey, what should I do? But the right way, if you're doing infrastructure as code, to use designated dependency automation and management tools. There are plenty of those tools out there. During the next couple slides, I will look through TerraGrant, TerraMate, and let's start with standard one, as I mentioned earlier, is System Manager Parameter Store. So imagine the situation where you have infrastructure team who is creating some resource like RDS database, and they just publish SSM parameter to a known location with known name, and then your application development team simply reading using data source from this location. So this way, they don't have to talk at all. They just read whatever is in that data source, and they configure the Lambda function through environment variable to pass this information. This is very simple to implement pretty much on any scale. Sometimes there are challenges because you need to figure out who actually has to be able to read this information, or you're attempting to put some secret stuff there. You can do this, but there are better ways to do this. So you need to be a little bit careful, but this is a very powerful way for lots of types of information. Let's look into another way, which is TerraGrant. TerraGrant has been around for a very long time, and I've been using it for many years, and I was pretty happy with the way how it abstracts away the need of going deep into Terraform modules. So like in this example, in order to pass configuration between Lambda function and an API gateway, all I need to do is inside of Lambda function TerraGrant HCL configuration file, I just create this Lambda function. And inside of configuration for an API gateway, I just specify that, hey, there is a dependency on this Lambda function, which is located in this local directory. And I just want to get a Lambda function IRN from an output of that module. That's it. As you can see, there is no Terraform code involved, no crazy syntax or no extra things. So I find this example very good, and this is, to my mind, one of the best sales points for using TerraGrant. This is, I like this approach as user very much. I also want to mention another tool, which is called TerraMate, which is not so well known yet, but it has very similar kind of flow, where you define stack configuration for the Lambda function, and you specify what kind of outputs will have to be exported from this stack. Like in this case, I output Lambda function IRN as an output. And then inside of API gateway stack, I simply specify that input to this API gateway module should come from Lambda function IRN. Syntax is a little bit harder to understand, and sometimes it can be a bit tricky to implement in pipeline. But in general, that's a level of separation which I think is pretty decent. And as we can see, API gateway module operate with this information natively using var reference, which means we don't have to rely on any environment variable being passed as a Terra grant, but it's just native Terraform code. And that's very good feature of TerraMate to my mind, because all it does is generate valid Terraform code, which you can execute even without TerraMate. So I think that's pretty much it from my side, because I want to give the clicker to Anton A, and he'll continue.
Thanks, Anton B. All right. So deploying at scale, right? We finally got to the deployment part, right? You saw several ways, right? So Terraform Apply will deploy your infrastructure configuration to the cloud, right? And it will store your state file wherever you define, right? But interesting challenges start where you have more than one, let's call it deployment, right? What if you have multiple teams, each one of them managing their own Terraform stack, right? Terraform configuration, and you have cross dependencies, right? As a serverless development team, you might be using the Lambda module that was created, right? But it still doesn't necessarily mean that your infrastructure team allows you to make changes to VPC, right? Or RDS instances. So Terraform is great when it comes to deploying those infrastructure as code configurations, right? But there are common challenges, right, when you use plain Terraform. And you've seen that addressed with parameter store. Do not save your secrets in parameter store. TerraGrant, right, TerraMate. But the question is there anything like Terraform native, right? Something provided by the Terraform itself. And the challenge is, what do you have multiple teams? Right, essentially, it's a multiple of everything. Multiple teams. How do you manage dependencies in infrastructure as code configurations across multiple teams? Multiple environments, right? Development, staging, testing, acceptance, production, and you probably have half a dozen production environments in different regions. Well, multiple accounts. You might be deploying to multiple accounts because some of your most demanding enterprise customers require you to deploy to a standalone account because of security and governance, right? But others are fine with shared accounts. Multiple regions, right? You're building your applications, cloud applications in multiple regions. So those are the interesting challenges that you need to start overcoming, right, as you're using Terraform at scale. Now, let me ask you a question. How many of you have already seen or explored Terraform stacks? Okay, I see 1, 2, 3, about 4. So this is a brand new feature announced about 2 months ago by Terraform, right? And this is something I want to talk about to wrap up today, because I think this capability maps amazingly well to the serverless world. Now, Terraform introduced this concept of stacks. Like I said, they briefly mentioned there's like a blog about it from last year, but they went full public with it. It's still a public beta, if I recall correctly, but they talked a lot about it at the HashiConf a little bit earlier this year, right? And the idea of Terraform stack, it's essentially a collection of resources, like components, and components, that's the official term. You will see the infrastructure as code as well, right, which define your application. Now, this can be things like API gateway, Lambda, S3, anything, any cloud resource. And those components, they are essentially mapped to modules, right? So as you will see, component is a reference to a module plus few configuration properties, right? How do you configure that module? Now, once you've defined your application, you have multiple components in your application, the next problem that we had is multiple environments or multiple deployments. So as part of your stack, you're defining your components, and then you're defining multiple deployments of that stack, right? And each one of those deployments will be an exact replica of it. Now, amazing part is those stacks are connected using outputs. So essentially, imagine you have a common services Terraform configuration, which deals with more of a traditional resources like RDS, KMS, VPC, Vault maybe running there, and you have a couple of serverless applications, right? Now, sometimes things change in that common services layer, right? So whenever those things are going to change, whenever an output is going to change, a change will be pushed to your application. Now, it's not going to be applied automatically. Don't worry. You can still, verify that everything works good. You still, do apply yourself, right? But your applications are getting all those updates, configuration updates automatically, which is really great for managing dependencies between teams without, sending an email or texting someone, hey, I've made an update, pull the latest version, right? Now, the way it works, if we start connecting all those building blocks together, right? Imagine the simple stack. API gateway goes to Lambda, goes to S3, right? The way it's going to be defined using Terraform, so you can see it on your screen. You got identity token at the very bottom, at the very top, sorry. Then you have a deployment, 2 deployments, right? One of them is development. That's my development environment. I'm putting that into US East 1 region. I'm going to be using a role specific to the development environment, right? And then I can have additional tags like environment equals development. The production deployment, as you can see, it actually runs in 2 regions, right? It's a different deployment, different configuration. And those are US East 1 and US West 1. Now, different role, right? It will be running using a different role because I'm using different roles for production, kind of makes sense. And I have different tags. So essentially, I'm defining different deployments which have different configurations, but are still using the same components. What am I getting as a result? Well, I'm getting 2 deployments. The development deployment will be in US East 1 with 3 resources. The production deployment will be in 2 different regions, but exactly the same components, okay? Now, let's take a look at how this actually looks. So I got a short demo here to show you this whole thing in action. Go. All right. So we'll start with my extremely complex Lambda function, hey there, reInvent 2024, right? Because like I said, we don't care about code, we care about infrastructure as code. Now, this is my S3 component. As you can see, it's just a mapping to a module. And I have a Lambda component, right? So 2 components, S3 bucket and Lambda function. No API gateway just yet. This is the definition of my development deployment, right? Exactly what you saw on a previous slide, okay? Now, if I switch to Terraform console here, you will see that my development deployment is already deployed. This is my starting point. It's already out there, okay? Let's start making changes. So the first thing I'm going to do is I'm going to paste the production deployment with a different role, but I'm just defining a different production deployment, right? GitOps forever, right? Committing the change. In a few seconds, you will see the change picked up by the Terraform console, so you can see that, well, development environment will become, deployment will become green right away because there were no changes. But production actually allows me to see the changes. And you can see changes to Lambda function to S3 buckets because I'm using 2 different regions. I can click Approve Plan, right, standard, right? And within several seconds, depends how many resources, there's standard Terraform apply going on in the back, under the cover. That will become green. Let's make more changes, okay? So we've added additional deployment, right? Now we're going to be adding additional component. So I'm going to add API gateway to my components. And you can probably guess what's going to happen now, right? So, and that API gateway is referenced in the Lambda function. So there are cross dependencies between these components. The moment I've committed that change, right, you will see that both development and production environments are being processed. I can see the changes, right? And development environment, Lambda and S3 didn't change, but API gateway was added. You can see the list of resources. So I approve this plan for development, not for production just yet. I need to separately approve it for production. And you can see more resources added because we're deploying to 2 different regions, right? So I made 1 change. It was applied across multiple deployments. Within several seconds, you will see that those changes were applied. Both environments are green. Everything is Git, right? You have full trail. And if I go to the resources that were just deployed, right, I'm going to take this URL of the API gateway that was literally just created. If I paste it into my browser, you will see, hey there, reInvent 2024, right? So that's my source code, okay? So this is a Terraform native way of actually managing dependencies across multiple components, right? And also deploying to multiple environments, multiple accounts, etc. I do encourage you to take a look at that, right? Because it allows you to manage dependencies, Terraform dependencies, across different teams at scale. So we got about 5 minutes left, right? Let's start wrapping up, and we'll be sticking around outside if you have any questions. So we love talking about this stuff. All right, so to conclude, we covered a lot of different topics today. Terraform and tools like SAM or LocalStack, they enable you to efficiently build and test serverless applications with tools your organization is already familiar with, right? So you want to build serverless applications, and you're already familiar with Terraform, awesome. Use Terraform for your serverless applications. You don't have to rebuild like your infrastructure as code knowledge, right? There are a few things that you will need to learn, like Lambda concurrency or properties of API gateway, but you can use the tool that you're already familiar with. Modularizing your Terraform configurations allows you to build reusable components and patterns, which are extremely critical in the serverless world. I cannot overemphasize this enough, right? This is one of the most successful techniques I see across customers that I work with. Modularizing and then providing this module as something, that vetted module within the organization significantly improves the efficiency in a multi-team organization. The third one is you're not alone. Look how many people we got here, right? We have over 300 people, 320 something if I recall correctly, right? And there were even more people in the line, right? And this session is streamed real time in another building. So you're not alone. There is a huge community of using Terraform for serverless, right? Leverage that community, be a part of that community, okay? So the more, the merrier. Use those open source community projects and samples that we built as part of AWS to accelerate your journey, right? We build a lot of reusable patterns and we just publish them for you so you can start using them. Next steps. I promised you a QR code, right? I always fulfill my promises. This QR code got literally everything you've just seen, right? And more and stuff that I haven't covered. So we have a guide for using Terraform for serverless applications available online. You'll see that link there. There's a workshop running in, if I recall correctly, 2 hours covering this specific topic. You can join that workshop if they still have seats available, right? But it's also online, right? So you'll find the link there. Terraform provider best practices, Terraform resources by Anton B., right? Governance for serverless applications guide, because Terraform is a great tool to use for governance. Various serverless patterns with Terraform. We have tons of content that you can reuse. Everything is available through this link. Feel free to reuse it in any way possible. There are 3 other sessions I would probably recommend you participating. So building serverless applications using Terraform workshop. It's essentially a hands-on workshop version of this talk, right? It's happening in Mandalay Bay in 2 hours, a little over 2 hours. So if you can still get there, that would be great. If not, it's available online publicly, right? So you can just, you'll find the link in the QR code that I've given on the previous slide. Best practices for serverless developers. That's an amazing session if you're building a serverless application. Happening in this room in 2 hours, okay? And implementing security best practices for serverless applications. Also, really good session that shows how to use Terraform and infrastructure as code tools to actually making sure that developers don't make mistakes because they're thinking about business scenario, right? They're not thinking, what's the right way to create this infrastructure resource, right? So this session will help you with how to implement security and governance using infrastructure as code tools. Continue your AWS serverless learning. We have, like I've mentioned, tons of resources at Serverless Land, right? Badges if you want to show your serverless skills. Serverless Kung Fu, right? And thank you so much for coming. I hope we hope this was useful, right? And if you have any questions, we'll be just outside to answer those.